So you should have this written down. We're going to do a bunch of examples, and you're going to do the examples with me. We're just going to recall a few things, think about a few things before we get started with the examples. So this is vertex form. We got A, H, and K. And what we've been working with lately is what do they do to the graph. So my vertex in this case is, not K, is H, K. A tells me if there's a reflection and tells me if there's a stretch or a compression, right? We summed all that up and we've seen all different types of things. What else can I get from this graph? Domain and range, or from the equation, sorry, domain and range. I can know the maximum value or the minimum value, the optimal value, right? The axis of symmetry. I can find the vertex, as we said, the growth pattern, and that's about what we can get from this equation. One thing we can't get is the intercepts. And it turns out intercepts are really important, not just for the math part of this stuff, but for when we apply quadratics to the real world. Intercepts are really, really important. Okay. So, and the vertex form doesn't give us the intercepts directly. Okay, we have to do a little bit of work to get the intercepts. So we're going to talk about Y-intercept first. And if I draw an axis, here's my Y, here's my X. I'm going to make that a little bit shorter. Where would I find a Y-intercept on that axis? Jaden?
X is 0 and then Y.
So give me, yeah, so where, go ahead.
Like 0,
3. So like that is a Y-intercept? You agree? Okay. How about this? Oh, and do you think that's a Y-intercept? Yep. How about this? Think that's a Y-intercept? What's true of all of those? Tara? Very good. So X is always 0 or X equals 0. Turns out that's really important. We think of, especially in grade 9, you think of the Y-intercept as where it crosses the Y-axis. But mathematically, algebraically, it's like where X is 0. When X is 0, the X part is the 0, that's where you get the Y-intercept. Okay? So what about X-intercept? Let's do that. So there's my X. There's my Y. Where would I draw an X-intercept? Riley?
Anywhere where Y equals 0.
Yeah, good. So what would that look like? Okay, so that would be one. That would be one. Right there at the origin would be one. There would be one. There would be one. And as Riley said, anywhere where Y equals 0. And turns out that's a really, that's just always going to be true for every kind of graph. So for linear relations, Y equals mx plus b, b is the Y-intercept. But unfortunately, we don't have that. There is no Y-intercept in vertex form, for example. Okay? So, but one thing that's always true is at the Y-intercept, X is 0. And at the X-intercepts, Y is 0. Right? That's always true. So that's going to help us find them. Do you remember when we were graphing, and sometimes, like the first day table of values, or when we started graphing with transformations, and sometimes you couldn't read the Y-intercept off the graph. Like it was too high or too low. You couldn't read it off the graph. So what do? Or what if the Y-intercept is not a perfect point? It's like a decimal or something. What do you do? Well, we can find it algebraically, right? Okay, so one more thing to think about. I don't want to say that. Consider, the possibilities. Okay, so I'm going to draw a nice big axis here. Somebody give me an example of a parabola that has some x-intercepts, what it looks like. It's a little bit hard to do, but can you describe it so that I could draw it? Like, how would you describe a parabola with some intercepts? Liam? Okay, and then which direction would it open? Okay, so it would look like this. So it would kind of go like that. Very nice. Good description. Using the transformations, the vertex is shifted down and it opens up. So how many x-intercepts does that have, Liam? Two. What else could I have? Yes, Mahmoud. Huh?
Vertex.
What do you mean vertex?
You could also have a vertex from that.
Oh, yeah, I could get it. Okay, yeah, I sure could, yeah. What are my other possibilities in terms of x-intercepts? Jaden, what do you think?
Possibilities.
Well, describe another, anybody, describe another parabola.
Well, the vertex could be up one and then opens down.
Okay, nice. And how many x-intercepts would that have? 1, 2, still 2, right? What? Can anybody think of something else? Above the x-axis, and what would it look like from there? What if it was above the x-axis and opened up? How many x-intercepts does it have? 0. What's another possibility like that? Alan?
A reflection, but
Of that one?
yeah, but then negative is below.
So below and opening downwards, is that what you mean? That would have 0. There's one more possibility. What else could this graph look like? Nice. The vertex is on, and if it opens up or down, vertex is on. How many do I have? 1. So those are the only 3 possibilities for parabolas. For other shapes, there are certainly other possibilities, like a linear can have 1 or 0. It won't have 2. Parabola can have 2 or 1 or 0. It can't have 3. And like I said, there's lots of other functions that can have other possibilities. But for the quadratic, for the parabola, those are the 3 possibilities. That's what they look like. Now, we know a lot about those kinds of graphs from transformations, like the equations. You could make up equations for graphs like that if you get this stuff. If it's clicking for you, you could look at an equation and tell which one of those cases it is. Is it shifted up, opening down? Is it shifted up, opening up? Right? You could kind of get a prediction. So if you think about that as you're finding the intercepts, that will help you with a bigger picture of all of this stuff. Okay, so let's try an example here. Jaden, you were going to ask a question. Do you still want to ask it?
If the parabola is so compressed that like stretched down a straight line and opens like that, that's still just 2 x-intercepts, right?
Yeah. It would, if it was, it could never be absolutely straight. It would always have a bit of a curve. So it would be really close to the x-intercept, but it would only touch it in a maximum of 2 places. Okay, so here we go. Let's find some y-intercepts and x-intercepts. This is a really crucial skill in whenever you're working with any kind of graph like this, is being able to find the x-intercepts and y-intercepts. The good thing is it's always kind of the same idea to get started. How the algebra actually looks can change, but okay, so you can copy that down. Get the first example copied down. So here's what we're going to do. We're going to find the y-intercept first. Y-intercept's always kind of easier. And the y-intercept occurs, what did we just learn? At x equals 0. And if you write that, every time you do this, you'll never forget it. Next year in grade 11, or like on the test for this unit, or for the next unit, or for the exam, you'll never forget it. You'll be like, oh, y-intercept, we did that months ago. Oh yeah, when x is 0. Okay, and all you do is y equals 0 squared minus 4. So I just sub 0 in for x, because it says x equals 0. What's 0 squared? 0. What's 0 minus 4? Pretty easy, so -4. And we're going to state the point again just because we're trying to remind ourselves that it's a point, not a line. It's not the line y equals -4, it's a point. It's a good idea to not get the 0 in the wrong spot. And the nice thing again about this is both of my answers are written here. So I know x is going to be 0 and y is going to be -4. So 0, -4. Pretty simple. Y-intercept is, in quadratics at least, is always the easiest. It's just bed mass. Okay, we'll see a couple more complicated ones, but it doesn't get hard. X-intercept occurs at y equals 0. Now this X-intercept's not going to be too difficult, but they do get a little bit trickier. But the nice thing is it's the exact same steps every time. So if you just practice it a few times, then you'll get it. Okay? And don't get caught up thinking, like when we do the last example, D, E, F, like there's a whole bunch, but when we get down there and it's a little bit trickier, don't go, wow, I don't understand any of this. No, 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 you do. There's some harder ones, but the easy ones you get. Start with the easy ones, work up to the harder ones, and try them. But remember the general idea that we sub 0 in for y and we start solving. And if you practice, you'll get there, okay? But a couple of them, it's just a little bit different, a little bit new. So there's one other thing about this that might kind of blow your mind. So that's going to come up in a moment here. So I'm going to sub 0 in for y. And you've done this before. This is not mind-blowing. How do I solve this equation? Because, see, the other one, everything was on the right, so it's just bed mass. In this one, it's not the case. This is like an equation that I have to solve. So, and then what do I do? Okay, so I'm going to add 4 to both sides. Very nice. And here's the trick. What do I do now, Megan? Square root of both sides. And what's the square root of 4? 2. Somebody tell me why the square root of 4 is 2. Like, what is the remind yourself, what is the square root asking? We've talked about it in this course, but you've seen it in previous years as well. What is the square root doing? Tara? It's 2 times 2 is 4. Very good. Exactly. Jaden, what were you going to say?
I was going to say the same thing. And x times x is x squared.
Okay, good. So the square root of x squared is x. Good, Liam? Yeah, well, kind of. You're from 4.
Yeah, sorry.
What number do you have to divide by to get back itself? Yeah, very good. That's a good way of looking at it. So in other words, it's asking, let's see if we can write this down. It's asking what number, this is what a square root does, right? What number do I multiply by itself to give me 4? And so it's 2. Is it? Isn't there another one? Rachel, what do you think? You don't think so? Can anybody think of another number that you multiply by itself and get 4? -2. Wait a minute. How are there 2 answers to one question? And why did nobody ever tell you that this was true? How long have you been taking square roots of things? Grade 6, grade 7? Is that when you learn about square roots? Last week? No, you didn't do square roots in elementary school. Not at all. You do them in grade 9 for sure. Anyway, but when you take a square root, yeah, because you do Pythagorean theorem in elementary school.
Oh, yeah.
So think about this for a minute. When you do Pythagorean theorem, you end up taking a square root. It's a length, which can't be negative. So you just take the positive version. When we did length in the last 2 units, we did length formula, which is square root, which is like Pythagorean theorem, right? Comes from Pythagorean theorem. It's also a length. So we just take the positive version. But your teachers have all been lying to you and thinking that the square root of 4 is 2. It's not. It's 2 and -2. There's both. And there always has been. Just when it's a length, we don't care about the negative one. So we kind of pretend it doesn't exist as teachers until we need it. And now all of a sudden we need it. So what we do, whenever we take the square root from now on, is we use this little symbol beside it. Plus minus. That's how you would say it, and that's what it means. It means there's actually 2. So then again, I'm going to put it on the 2 plus or minus 2. Therefore, x equals 2 and x equals negative 2. And I get 2, 0 as one of my x-intercepts and negative 2, 0 as my other. And doesn't that make sense? Like, let's graph this. You can just look at mine. You don't have to graph it. If I look at x squared minus 4, what is that? Well, it's got to shift down 4, and it opens up. So doesn't it have to have 2 x-intercepts? If I took the square root of 4 and only got positive 2, I'd be ignoring half the parabola. Can't do that. So it turns out there's actually always been 2. We've just never needed it until now, but now we need it. Ziggy.
What happens when the parabola shifts like left or right, and then the x-intercepts, like they won't both be 2?
Yeah, it's a great question. We're going to find out when we do an example that looks like that. Not the next one, I think, but the one after that. We're going to find out what the math looks like. But the math will work. That's a great thing about math. It always works. Everything just fits and makes sense. It always works in mathematics. It's not always easy, but it always works. Okay, so the lesson here is a really important lesson. Always plus or minus. There's 2 square roots always from now on. And if you did a test and you did let's say 3 or 4 of these, and you found 1 x-intercept for each of those, if you were thinking, you'd be like, this doesn't make any sense. A quadratic should have 2 x-intercepts. Why did I only get 1 for each one of these? You probably forgot the plus minus, right? And you didn't get 2. There are cases where you get 1, but we can recognize them. And so we should know what they are. And if it's not that case, you should be getting 2 or you should be getting 0 or something like that, okay? Okay, let's try another one. So take a look at this. Question B, y equals x minus 4 squared. So you know the transformations that are happening. You can picture what that looks like and make a prediction about how many x-intercepts we're going to have and what they're going to look like and that sort of thing, right? Like you could make a prediction. We're not going to, but you could. So we're going to start with the y-intercept first, which occurs at x equals 0, right? Y-intercept at x equals 0. Go ahead and try it. This is where BEDMAS comes in. How does BEDMAS work? That's just rhetorical. You don't have to answer, but think about it. How does BEDMAS work? And see if you can answer this yourself. Yes? No, don't do x. So, so BEDMAS tells me I do what first? Brackets. What's 0 minus 4? Negative 4. What's negative 4 all squared? 16. Therefore, x is 0. It says so right up there. And y is 16. It says so right there. 0, 16. Okay. See what I mean? Y-intercept's easy. But you can make mistakes. It does get a little bit trickier, but as long as you're just careful of your BEDMAS, you'll be fine. Okay, the y-intercept occurs at, the x-intercept occurs at y equals 0. So this one is the harder one. But we're doing it in progression, right? So remember, the last one wasn't hard. We're only adding little steps. So you can do each one of these steps. And the great thing is, the steps are identical every single time. Okay? Except for maybe if you skip a step because you don't have to do it, right? But otherwise, they're identical. So even if it looks like a hard question, remember, you just do the steps in the same order, and you always get to the answer, okay? But it is a little bit new, and it takes a little bit of getting used to. So I have to pull this apart bit by bit. I'm actually kind of going to do it in reverse BEDMAS order. I can't do the brackets because there's an x in there. So what am I going to do first here? Yeah, take the square root of both sides. So remember I said you should have plus or minus, but square root is plus or minus square root of 0 we don't actually need to worry about that because what's the square root of 0? 0. There is no plus minus 0. And the square root of x minus 4 all squared is just x minus 4. So I've got 0 equals x minus 4. What do I do now? Add 4 to both sides. And I only get one answer. What do you think about that? Who can explain that? And doesn't that make sense from what you know about transformations? That's a shift to the right by 4. It doesn't move up or down. So it's just sitting on the vertex, or sitting on the x-axis, right? The vertex is just sitting on the x-axis. So it makes sense that we would only have 1 in that situation. That's what that would look like. Does that make sense? Any questions before we move on? What if I have both? So the first question had a vertical shift, the second had a horizontal. What if I have both? We'll do the Y-intercept first. You go ahead and try it. I'll get us started, but so what do I do here? What's 0 plus 1? 1. So 1 squared minus 4. What's 1 squared? 1. What's 1 minus 4? Negative 3. So 0, negative 3. How many people got 0, negative 3? Awesome. Easy, right? You don't have to show all those steps. We'll see. We'll do an example where we don't show all those steps. For that one, you really don't need to. In fact, for the next one, it seems strange, but like even when they start getting harder, like I said, it's the same every time. If you practice this enough, you could even do X-intercepts in one step, just because it's so repetitive. Which people won't believe me at first, but you've done harder things, I'm sure, and if you practice it enough, you get good at it. It gets so easy. Okay, so what am I going to do first here? This one, this is where they start to get a little bit trickier. Can't do that, because whatever I do, I have to do to both sides. So if I take the square root now, I'm going to make a mess of stuff. So I'm going to move the 4 first. If that's what I did last for the Y-intercept, so that's what I do first for the X-intercepts. And that's like by design, that's how that works. So I get 4 equals x plus 1 all squared. Now, I can take the square root of both sides, right? So plus minus the square root of 4. And notice how I'm putting a tail on the end. That's what we call that little line that goes down. There's a reason for that, okay? We'll see in a moment. So it's a good habit. That's why, like, we have to be careful for square roots where they end. So what's the square root of 4? 2. So plus minus 2 equals x plus 1. So now I move the 1 over, subtract 1 from both sides, and I can write this 2 ways. It really doesn't matter which way you write it. I'll show both just so that you see what it looks like. Negative 1 plus or minus 2, or plus or minus 2 minus 1 equals x. That plus or minus sign is really, really important. Once we have it, we got to keep it the whole way. Yes? No. That's 2 different ways of writing the same thing. So now I'm going to solve these. So one of them is going to be x equals, it's not like one comes from the left and one comes from the right, but I have 2 answers here that says x equals negative 1 plus 2 and x equals negative 1 minus 2, right? So I've got both. So I've split it up into 2. You have to do this because we got to find both. And what's negative 1 plus 2? It's 1. And what's negative 1 minus 2? It's negative 3. So Ziggy, remember when you were asking what it looks like? There you go. Right? So you have that extra step where you actually have like an expression with a plus minus in it and a bunch of numbers, and then you evaluate each of them separately. Yeah.
Why is it negative 1 plus 1?
Because I subtracted 1 from both sides. So that was when we were talking about square roots before. Remember when we talked about how a square root actually has 2 answers. They always do. So let's take a look at this one. It was x plus 1, right? All squared minus 4. So there you go. I've got a y-intercept at 0, negative 3, and 2 x-intercepts, one at 1, 0, and one at negative 3, 0. Right? The graph matches, and it should. It better. Otherwise, something's wrong. That's what I mean about math always works. Everything always fits. So Alan, whenever you take a square root, take a look at that, right? From now on, you write plus minus with it. And then you get in the habit of doing that, and you'll always see 2. Okay, we're going to try, yes?
So if there's no vertical shift at all, then there's only one intercept, and we just signal the plus minus.
Yeah, you wouldn't need it because it'll always, in that case, it'll always be the square root of 0, and 0 doesn't have a plus minus. You can either write it when you take the square root and then drop it in the next step, or you could, yeah, just not worry about it, as long as you understand that. Shaden.
When you split up like the two x's, you write both the same equation,
Yeah,
and then you write like a separate
one with a plus, one with a minus is how you would typically write it. So, like, I wouldn't write both of these, right? I would only write, I don't write both. I would only write one of those. And then the next step, I'd write one of them with plus and one of them with minus. I'm just saying you can write it with the plus or minus to first or second, like you can do both. Okay, let's do the y-intercept. You can do this yourself. This is the one where it's like you got to be a little bit careful of your bed mass, and some people might make mistakes here. Go ahead and try that. We're getting all different kinds of answers. Okay, so let's take a look at this together. Bed mass. What does bed mass tell us? I start with brackets. What's 0 minus 6? Negative 6. So I will show my steps for this last one. So that's the B. What's the E? Ziggy, what's the E? Exponent. What's negative 6 all squared? Evan? 36. So I do it like this. Some people multiplied by 6 and got negative 12. Whoops. So I've done the B, I've done the E. Now I do divide and multiply. There's no dividing. So what's 2 times 36? 72. 72 minus 5, 67. So if you got 67, that's awesome. If not, be careful of your bed mass. Watch this. If you have a decent calculator, watch. 2, bracket, 0, minus 6, bracket, squared, minus 5. It looks exactly like it looks on paper. Hit equals 67. How easy is that? You don't have to show your steps. This is grade 9 stuff. I'm not testing you on your bed math skills. I would hope that you could do it with a little bit of practice, like, refresher. But if you can't for some reason, then learn how to use your calculator, no problem. Okay? But make sure you can get the right answer. All right, next one. So this is where, again, like now I've got everything here. So I got to pull the pieces over one at a time. I'm doing it in reverse bed mass order because that's how we solve equations, typically at least. And so it gets a bit tricky. And this one doesn't work out perfectly. I get decimals. So It's going to look a little bit weird the first time seeing it, but trust me, it's actually not that bad. And like I said, it's exactly the same steps every single time. So once you've practiced it a few times, all of a sudden you realize like, oh, actually this isn't that bad. So what do I do first?
Bring the 5 over to the
Bring the 5 over. What would I do next? Tara? Oh. Reverend Preet? Divide by 2. Because I don't want to take the square root of that 2 out front. I want to get everything over so I just have the squared part left on the one side. So 5 over 2 equals x minus 6 all squared. Now I can take the square root, plus minus, and the square root of 5 over 2 is going to be nasty. Square root of 5, this is my fraction button, by the way, over 2. Yuck. Don't take that and round. Oh my gosh. No, 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 no. Just leave it as square root of 5 over 2 for now. You got to get used to writing things this way. If that doesn't feel nice to you, you got to get used to it. Okay. So this gives me plus minus square root of 5 over 2 equals x minus 6. Now what do? Add 6 to both sides. And again, I could write the 6 first or last, it doesn't matter. So I'm going to do this. 6 plus minus square root of 5 over 2 equals x. Therefore, x equals 6 plus square root of 5 over 2, and x equals 6 minus square root of 5 over 2. This is the exact form. If you read the question, it said answer with your exact form and then to 1 decimal. Okay, so that would look like this. 6 plus square root of 5 over 2. And 7.6. And then I can just scroll over and change my plus to a minus 6 minus the square root of 5 over 2. Gives me 4.4. So a little bit trickier. I'm going to do 2 more examples because I just show 2 different cases. We'll try to get through them quickly. Any questions? Why don't you try the Y-intercept again? I'll give you just a minute to try that. No, it doesn't make it wrong. It'd just be a little bit more confusing for somebody who is just learning it. Okay, so let's take a look at this. I subbed it in all into my calculator, and I just hit equals, and I got -8. So see what I mean? You don't have to show your steps. If you can do it on your calculator all in one step, do it. And you don't have to do it all in one step. Like you can do it bit by bit. 5 squared times -1/2 plus 4.5. Okay. Let's do the X-intercepts. at y equals 0. So 0 equals negative 1/2. So this example is just like, what do I do when I have a fraction? So we're going to move the 4.5 over first. Negative 4.5 equals negative 1/2 x plus 5. In fact, if you just want to, if you want to not copy this one down right now, you can copy it down after. If you just want to watch, that might work. What do I do to get rid of the half? That's the question. What would you do if you were solving this and you had to all of a sudden get rid of the half? Rachel. Multiply by 2, nice. And I'm going to make it negative 2 since it's negative 1/2. But exactly, how many people were thinking that? Multiply by 2, awesome. So I multiply both sides by negative 2. Negative 2. And so that crosses out all that stuff. And what's negative 4.5 times negative 2? Well, it's 9. And then from there, it's easy, right? I take the square root of both sides, got a plus minus. What's the square root of 9? Plus or minus 3 is x plus 5. Subtract 5 from both sides, so I get negative 5 plus minus 3 equals x. So x equals negative 5 plus 3, and x equals negative 5 minus 3. Does that make sense? So negative 2 and negative 8. And again, if we graph that, that's what we'd see. We'd see those two answers. Any questions about that? Okay, for this next one, I'm going to skip the Y-intercept. It's not super interesting. I want you to put your pencil down and just watch. If you thought about the graph of this, you could predict the final outcome. But my question is, what does it look like algebraically? What kind of a shift does that have? What direction does it open? You could guess what's going to happen from our little demonstration of the possibilities before. But I'm going to do this. X-intercept at, let's say I forgot about that. I didn't think about it, and I just started going, okay, X-intercept at y equals 0. And I sub in 3x minus 2 all squared plus 4. So what do I do first? I subtract 4 from both sides. Then I divide by 3. Then I take the square root of both sides. So I'm just going to keep going. Plus minus square root of negative 4 over 3 equals x minus 2. Then I add 2 to both sides. And I get 2 plus minus the square root of negative 4 over 3 equals x. Then I go to my trusty calculator. I go, okay, 2 plus the square root of negative 4 divided by 3. And I get an error. Why? What happened? Why did I get an error? An ing. There is no x-intercept. So it makes sense that there's no solution. If it said 5, 5 would have to be the x-intercept. And I just said to you, math always works. If it can't give me a numerical answer, that wouldn't match. Okay, so now, mathematically, can anybody tell me why I got an error? Jaden, what do you think? Can't take the square root of the negative number. No number times itself will give you a negative. You try to do the square root of any negative number. Like 25 has a square root, but the square root of negative 25, no, it doesn't work. Because the number times itself can't be a negative. 5 times 5 is positive 25. Negative 5 times negative 5 is positive 25. So we would say, therefore, no x-intercepts. Okay. The work for this is posted in the classroom. Question 6 and 7, but only do the odd ones, so ACE, ACE. And the instructions tell you to do other stuff, like graphing. Don't graph, just the intercepts. That's all you have to do. You don't have to graph. You don't have to do anything else. Just use those questions, every other one, ACE, to find the x-intercepts, and y-intercept. Okay? There's always one y-intercept. There's never more. There's never fewer. There could be 2 x-intercepts, 1 x-intercept, or none.